Alright, so let's jump on to our next video. As you can see, the amount of rainfall that we're collecting per acre. These numbers are based on 12 inches, but then again, you understand that this chart will be based on areas that receive 120 inches of rainfall to represent 1/3 of the day, which is 8 hours in a day, and we can tell you how this will work out here. So what we did is to find how much rainfall we receive each acre is we converted acre foot to gallons. Acre foot to gallons, you can do that Google search here. 1 feet means 12 inches. So what we did is 120 inches into 10 feet became 10 inches. So 10 feet right here. Sorry about that. 10 feet into 10 divided by 10 months. What that means, 1 foot per 1 month. So basically this kind of estimation is for each month. So let's go on to our other sheet. As you can see, this is good snowfall. There are areas receive good snowfall, but we can talk more about it, but the areas that are stated on the website don't receive too much snowfall. And as you know, there are areas that receive more than 120 inches of rainfall too. There are areas that receive 240, 300, 350 in Burma actually. That's Myanmar in Asia. So Hawaii actually has averaged over 200 inches, so that's pretty good. So let's talk about each gallon weight. 7 pounds per gallon. We multiply that by 18.85 becomes 132. As you can see here, 18.5 gallons per second is what we're using right now. So just to go above on it, we will be using Kaplan turbine here, which I stated in the last video, this one, and we will go like this, not like this, just to make sure again. So we will look at the mass of each blade. It will be 12 pounds, 4 blades. This is the mass of shaft. Total weight of the turbine is 56. RPMs required is 69 to 429, depending on how much coils will be in the generator. More the coils, expensive the generator. So weight of the liquid divided by mass of turbine. 132 pounds of water being put on 56 pounds of turbine gives us the amount of force in 2.36 meters second square. Now we need to consider the gravitational force also, because you can understand this is weight, so this is moving object, this is dead weight. Turbine is right now dead weight until it doesn't get hit by the liquid. So the amount of force will be 23.1. This is the gravitational force that we use. So we multiply that by 2.36. Now how to calculate the RPM? Now this is a simple formula, not too difficult. This is a linear velocity. This is angular velocity that we calculate, and this is the radius. So now just to show you how we actually came up with this kind of formula, let me show you. Here we go. It's circular motion. So when rotating object, there's a relation between this. As you can read this. This was the formula, angular velocity. So now what we do is 23.1. This is how we got that number, the linear velocity, and we divide that by the radius, which is 5 meters. And later on we get 4.62 RPMs per second, just to make sure, just a second, because we calculated the numbers in seconds. So now we take the RPM and we multiply that by 60 and we get 277 RPMs. So just to make sure again, Kaplan uses 69.2 to 429. So that really gives us a head-on that we can reach that level with the amount of water we collect and the amount of energy we can generate. And now let's talk about how much energy we generate. Very simple to understand. So as I said, 8 days of generation, 325 into 8 hours, 2.6 megawatt hours we can produce. Per month 78 megawatts, per year 936. And if using two generators based on our small investment module, we'll get 1872 megawatt hours. And yeah, 872 megawatt hours. So that is, then we get into the years, and sales per year, we multiply that by 0.05 cents, and we get all those numbers. So if you have more questions about the technology working or anything about the numbers, please let me know. Thank you, and thank you for watching. Thank you.